Hi, everybody. My name is Bill Troutman, and this is the Week 4 live chat. We are covering section 3.3 and 3.4. Um, here we go. First, before I even wanted to start off, I do want to go back and just take a quick look at our modules. If don't forget, when you click on modules, we are in week 4, so you scroll down to week 4 module, and test number 1 is there, and it's due this Sunday. So you must take test number 1 by this Sunday night. Now, Sunday night. Now, I'm going to tell you right now, if you try to take it at 11 o'clock at night and your power goes off because it's supposed to rain this weekend and your power goes off, you're going to get a 0 on that test. I give them one makeup test at the end of the semester, but you'll have a 0 on that test. I mean, if you miss more than one test, you can't make up. You can only make up one test. So don't wait. What I'm trying to say is don't wait till the last second to take this test. Sunday during the day, Saturday, Friday, don't wait till the last second. We're supposed to have rain again this weekend, and I don't want you being stuck and saying, oh, Sunday night at 11 o'clock, my power went out. Yeah, you get a 0 on the test. I know that sounds harsh, but I mean, in reality, you should be taking the test hopefully before then. Okay, so that's what I wanted to say. I'm also going to post a video in the week 4, and then I'm in the announcement, and I'm going to send it to you on how I want your camera set up when you're taking the test. So you have to use Respondus Monitor, and I'm going to send you a little video. It's like a 2-minute video on how the camera should be pointing when you're taking a test, because some people point the camera in weird directions and I can't see anything. I should be monitoring you when you take the test, or have the ability to monitor you. So that's all I wanted, and be on the lookout for that later on today. I'll post that in the module and in the announcement section. So today, I am covering section 3.3 and 3.4, and that's just one homework assignment combined. Also, there is a review in the homework. Make sure in the homework section, make sure you do that review. That will help you on the test. So work that review out. And if you do well on that review, you're going to do well on the test. The test is multiple choice. So the test is going to be harder than the review. The review, you have to type in answers and do other things. For our actual test, it's all multiple choice, so you just have to pick the correct answer. So work out that review in the homework section. Do all the homework, make sure you work out that review, and then take that test before Sunday night. I definitely would try to take it on Friday or Saturday. Friday it's supposed to rain also. All right, so here we are. We are on section 3.3 homework and 3.4. Let's get right into it. And we're talking about linear equations and things. So first of all, it says find the slope that's passing through these 2 points. So before I go, I just want to show you, here's the x-axis, here's the y-axis. The point negative 9, 8, this is negative 9, and then this is positive 8 up here. Negative 9, 8 is right here. And the point negative 4, negative 3 could be right here. Negative 4, negative 3. Wait, negative 4, negative 3. That's not it. Negative 4 is here. However, negative 3 for the y is down here. So the question is, what's the slope of this line if we connect those 2 dots? Well, here's a symbol for slope. The formula for slope is y2 minus y1 divided by x2 minus x1. So for this next test, I would definitely have this formula written down. These are 2 points that I have. This is the first point. This is the second point. This is the x of the first point. This is the y of the first point. Here's the x of the second point. Here's the y of the second point. So we just plug those numbers into the equation. Y2 minus y1 divided by x2 minus x1. It's really important that you use parentheses and then plug the numbers in the correct spot. Y2 is negative 3. Y1 is 8. X2 is negative 4. And x1 is negative 9. So then you just do the math. Negative 3 minus 8. And if you're not sure, plug it in the calculator. Negative 3 minus 8 is a negative 11. A negative 4 minus a minus 9. Well, minus changes to a plus. So this is negative 4 plus 9, which equals a positive 5. And there's my slope, a negative 11 over 5. Don't change it to a decimal. Don't change it to a mixed number. Leave it as an incomplete or leave it as a improper fraction where the top is higher than the bottom. So that's the first one, how to calculate the slope when you get 2 points. You use the slope 2-point equation. You label 1 as a first point. You label 1 as a second point. X of the first, y of the first. X of the second point, y of the second point. Plug them into the equation. Do the math on top. Do the math on the bottom. Try to reduce it if you can, and then you're done. Any questions? You're the only one here, Colin. So anytime you have a question, just jump on in. Sure thing. All right, so here's the next question. Oh, it's the same thing. Find the slope when we have 2 points. Once again, the slope formula, M stands for slope. I don't know why. Y2, I'm gonna go a little lower with this. Hang on. Y2 minus Y1 divided by X2 minus X1. This is the first point. This is the second point. This is X of the first point, Y of the first point. X of the second point, and Y of the second point. I'm going to rewrite this equation with parentheses so I can plug the entire number and its sign in there. So Y2, here's Y2 is a negative 3. Y1 is 8. X2 is negative 6. And X1 is negative 6. When I do the math on top, negative 3 minus 8, it says negative 11. Now on the bottom, put that into your calculator and see what you get. So I'm using the TI-30X here for this. I'm going to type in, and I'm using the parentheses too. Parentheses, negative 6, close parentheses, minus negative 6, and you get 0. Now, I do want to caution people when they type this into the calculator. This is a negative 6. It's that negative in the lower right-hand corner of your calculator. And then this is a subtraction sign. And this, once again, is that negative button. So if you don't type it in, sometimes you get, it won't take a subtraction for a negative. But we get 0. Now, on our calculator, let's type in negative 11 divided by 0, because that's what this fraction is. Negative 11 divided by 0. And my calculator says there's an error. And so, there has to be an answer for this. When you have 0 on the bottom, when you have an error like this is called an undefined slope. You can't have 0 on the bottom. So this is an undefined slope. In other words, it says indicate whether the line through the point rises, falls, is horizontal or vertical. Undefined slopes are vertical lines. It's an actual vertical line. So if they ask, what is this? It's a vertical line. And by the way, I'm going to show you on a graph that it is a vertical line. The point negative 6, 8, it would be right here, negative 6, 8. Negative 6, negative 3 would be right here, negative 6, negative 3. Do you see if I connect the dots? It's a vertical line, straight up and down. Vertical lines have undefined slope. So it's a vertical line and it has an undefined slope. Now, I'm going to erase this now. By the way, it's being recorded, so you can always go back and watch this in the recorded world. I'm going to erase this now. And what if, I'm just going to show you really quick, what if I had this 5, 4, and 3, 4, where if, see here, the x's were the same, so it's undefined. However, here the y's are the same. And if I did this y2 minus y1 over x2 minus x1, oh, that's a positive 5 here. So I would get 0 over 8, or 0 over negative 2. 0 divided by negative 2 on my calculator does say 0. Does say 0. So this does say 0. So this slope is the slope, by the way, the slope does equal 0. If you have a 0 on top, the slope does equal 0. 0 slopes are horizontal lines. It's a horizontal line. And if I graph this, 5, 4 would be here, and 3, 4 would be here. Do you see if you connect the dots? It's a horizontal line. So I just wanted to add that in there. Vertical lines have 0 on the bottom of the fraction. Horizontal lines have 0 on top of the fraction. Okay. Here's the next problem. I broke it right out of the book because we need to find the slope for this also. And there's 2 ways of going about it. If you look at this graph, there are 2 points. Well, let's label the 2 points. This point looks like 2, 1, 2, 3, 4. I can't really see it. It's not that close. I think it's 2. It looks like it's 2, 4. The other point here is 1, 2, 3, 4. Negative 4 and a positive 2. So here's... Oh, you're absolutely right. Negative 4, negative 2. Thank you very much. So this is my first point. This is my second. This is x of the first. This is y of the first. This is x of the second point. This is y of the second. If I plug those numbers into the equation, y2 minus y1 divided by x2 minus x1, I'm going to write it up here, y2 minus y1, y2 minus y1 over x2 minus x1, and plug the numbers in, I get a negative 2, 4, negative 4, and 2. Here I get a negative 6, and on the bottom I get a negative 6. Negative 6 divided by negative 6 is a positive 1. Our slope is a positive 1. So that's one way of doing it. Since they give us 2 points, write out the 2 coordinates of the 2 points and use the formula. Now there's another way, and the slope is also the amount the graph rises. Rises means going up or down. Up is positive, down is negative, and over the run. And run means how much it goes to the right, which is positive, how much it goes to the left, which is negative. So if you look at this, we start at the first point. To get to the second point, we rise 1, 2, 3, 4, 5, 6. And we're going from the first point to the second point. We're going up 6 spots. Up means it's a positive 6. Then we're going to go to the right. 1, 2, 3, 4, 5, 6. And to the right, the run part is 6. So we went up and to the right, 6, 6. 6 divided by 6 is 1. So either way, we got a 1 slope, a slope of that equals 1. So both ways, we got a slope that equaled 1, here and here. So you can use a formula, or you can just go from one point to the next, how much it rises and how much it runs. As if you go up, it's positive. If you go down, it's negative. If you go to the right, it's positive. If you go to the left, it's negative. So that's the rise and run way of finding the slope if you have a graph. All righty. And we're moving on. Let's say I have a graph. Let me draw my axis. Here's the x-axis. Here's the y-axis. And this line here, I think I could draw it a little bit better. This line here is my graph. I didn't mean to do that. I don't know how I even did that. Let's see if I can, yeah. So this is a horizontal line. Slopes of all horizontal line equals 0. So I already said that in the previous slide. This one right here, this is a horizontal line. Do you see how the slope equals 0? Horizontal lines, the slope equals 0. Vertical lines, the slope is undefined. So all horizontal lines, the slope equals 0. Now, there's another way you could have did it. You could have just picked 2 points. Let's call this y5. You could have said x is 0 and y is 5. This coordinate right here, 0, 5. And then you could have did this coordinate. X is 3 and y is 5. This coordinate could be 3, 5. And if you, once again, the change in y, 5 minus 5 on top becomes 0 on top, and 3 minus 0 is 3. Do you see 0 divided by 3 on my calculator says 0. So you can see all horizontal lines, the slope equals 0. Okay, so that's that. Any questions so far? Are we okay? I think we're okay. Good. So here's a great question because this is easy. If I can get an equation to look like this, y equals mx plus b. In other words, the y by itself, then whatever is next to the x is our slope. By the way, the b part, that's called our y-intercept. It's where our graph crosses the y-axis. So if I can get y by itself like this equation, then the number next to x is our slope. Find the slope. There it is. Our slope equals 6. That's it. If I can get the y by itself, our slope is the number in front of x. And it's already by itself, so we're done. This is called, by the way, this is called the slope-intercept equation right here. This is the slope, and this is in slope-intercept equation. The slope-intercept equation. And I think I talked about this last week. We showed the different forms of equation, either last week or the week before that. I think it was last week. Alrighty. Okay. So this is, let me draw my x and y axis again. Here's my graph, x and y. Visually, people have a hard time with this. Visually, y equals 5. This is an equation. To better understand y equals 5, we might want to put a t table here and try to create some points. Do you see how this is an equation? Even though it just says y equals 5, it's an equation. In other words, it's saying y equals 5. So there's a coordinate where y equals 5. The question is, what does x equal? Well, if y equals 5, x can equal anything you want. So I'm going to put a 0 here. You can put anything you want. So I'm going to do another point. The equation is just y equals 5. Pick a number for x, 1. The equation is y equals 5. Pick a different number for x, 5. So let's draw these coordinates. These are dots on a graph. 0, 5, right? This is 0 on the x-axis. Then here's 1 on the x-axis, 1, 5. This is 0, 5. This is 1, 5. Then we got to go 5, 5. Here's 5, 5, 5. If we connect the dots, we have a horizontal line. Find the slope. All horizontal lines have a slope that equals 0. Remember, you can put these 2 points in there. The change in y, 5 minus 5 is 0. And then the bottom, 5 minus 1 is 4. 0 divided by 4 is 0. All horizontal lines have a slope that equals 0. Okay? So that's kind of important. Did I do the other one here? No, I didn't. So I'm gonna erase this now, and I'm gonna look at another equation. Let's say this equation is x equals 5. So if I did a t-table, x always equals 5. Y can equal anything it wants, 0, 1, 2. So if I do this, x equals 5, 0, 1, 2, 3, 4, 5. 5, 0 is right there. 5, 1 is right there. 5, 2 is right there. Do you see? It's a vertical line. X equals is a vertical line. And the slope of all vertical lines is undefined. So what's the slope of, if you have an equation that says x equals negative 5, this slope is undefined. X equals negative 5 doesn't mean it's a point. It's a vertical line, and x is always going to be 5. Y's can change, but the x will always equal 5. All righty. Let's graph this. By the way, I think I typed it in wrong. It should say y equals negative 5x plus 3. So once again, here's my graph paper. I really should have better graph paper. This, once again, it's in slope-intercept form. Slope-intercept. In other words, y by itself, the number next to x is the slope. Our slope is a negative 5. Another way of writing the slope of negative 5 is negative 5 over 1. And this is 3. This is b. b equals 3, a positive 3. b is the y-intercept. So when you want to graph this equation, y equals negative 5x plus 3, step 1 is put dot on y-intercept. In other words, my y-intercept is 3. 1, 2, 3. This is where my graph crosses the y-axis at y equals 3. That's the y-intercept. Now, from this dot, I'm going to use the slope. My slope is negative 5, 1. Remember, the top is the rise going up or down. The bottom is the run going right or left. So the top is negative, so we're going to go down, and the right, and the 1 is positive, so we're going to go to the right. So from the original spot, we're going to go down 5, 1, 2, 3, 4, 5, and then to the right 1, and we're going to put a dot. And you can do the slope again, down 5, 1, 2, 3, 4, 5, to the right 1. And if you notice, there's our slope, if I drew it better. You can connect the dots, and there's our slope. There's our graph, sorry. So to graph this thing, you first need to put a dot on the y-intercept. And then step 2, use slope to find more dots. Let's see. Is the next one similar to this? No. So I'm gonna erase this and try a different one to show you. So let's do this equation: y equals 2/3 x plus 4. So here's my graph, x and y. And the first thing you do when you have it in slope-intercept form, you put a dot on y4, 1, 2, 3, 4. And then you use your slope. They're both positive, so we're going to go up 2 and to the right 3. So from here, we're going to go up 2 and then to the right 1, 2, 3 and put a dot. Then we're going to go up 2 to the right 1, 2, 3 and put a dot. And there is our graph. Put a dot on the y-intercept, use your slope to find the next point. Just moving along. I feel like I'm going too fast. All right, so let's see what we have now. How many more do you got? 1, 2, only 2 more. So let's take a look at this. It says put equation in slope-intercept form. So slope-intercept form means y equals mx plus b. In other words, we want y by itself. Look, I have y and x on the same side. So to put it in slope-intercept form, I just need to take the 3x to the other side. Keep the y there, but get the 3x to the other side. How do I take the 3x to the other side? Well, it's a positive 3x. Go ahead, Colin. Did you have a question? All right. Yes. Well, it's a positive 3x, so to get rid of it to the other side, you subtract 3x to both sides. So, and 3x minus 3x ends up being 0. So but we're still left with that y. I'm sorry, 0 plus y. This becomes 0. The y is still there. Then I have negative 3x plus 7. I'm going to put the x first because that's in my slope-intercept form. The x is first. So 0 plus y is y. And this is my equation. We're done. As soon as you get the y by itself, you're in slope-intercept form. So as soon as you get that y by itself, it's in slope-intercept form, and we're done. Okay. Okay, and I have one more question. What is the equation for this line? So once again, I'm going to use y equals mx plus b. Now look on this graph and tell me where the graph crosses the y-axis. Exactly at 2, at y2. That's this. This is called the y-intercept. So that's a plus 2, y equals mx. The only thing we need now is what the slope is for this line. So if I could do rise over run. I pick one point and I go up 1, 2, 3, 4, 5, 6. I went up 6, positive, and then to the right 1, 2, 3, 4, 5, 6. So this is up 6, to the right 6. 6 divided by 6 is 1x. So the slope equals 1. My equation is then y equals 1x plus 2. My slope is 1. But when you have a 1 in front of an x, it's not proper to put it there. The 1 should be invisible. So there's still a 1 there. But when you have a 1 in front of an x, you don't put it there. It's just understood. 1x is the same thing as x. So this is the equation for this particular line. Now we could have used those 2 points and found the slope that way. We would have still got 1. Or you could use the rise over run also. And that's all I actually had. That's 3.3 and 3.4 homework. I think there are 18 problems in the homework. And they're very similar to the ones I just did. I mean, that's where I got these problems from the homework. You can see this is the homework page. So your homework should be very similar to what I just did for 3.3 and 3.4. This is the last section you need to do before you're taking the test 1. Don't forget, test number 1 must be completed by this Sunday at midnight. Do not wait till Sunday to try to do the homework or anything. Finish that homework now. That homework should really be done by tomorrow. And then start doing that review. Review for that test. That review is in the homework section. Go below 3.4 and you'll see test number 1 review and work out that review. If you do well in that review, the test is going to be a breeze because the test is multiple choice and you'll just hopefully do well because it's very similar to the homework, other than the test is actually easier because it's multiple choice. Any questions? The review, yes. Oh, and I'm gonna let me hit stop